My name is Ilya Benish, and I'm a building analyst and Arctic construction manager for the Cold Climate Housing Research Center here in Fairbanks, Alaska. And the subject of today's video is a 20 by 24 cabin built about 23 years ago, and it has a wood paneled ceiling. And this cabin has had a history of water leaking out of the ceiling for years. We are now at a point where we are removing the paneling, and we're going to identify the source of the moisture and then also chart a path forward on how to solve the moisture problems. So here is the issue that brought us here in the first place. Every spring, as outdoor temperatures warmed up, this log gable end right up here where the paneling intersects the logs would become saturated with water, as evidenced by the water stains here. And in cases like this, we have to rule out a roof leak first, because sometimes it can also be a roof leak. And so we've looked at the roof metal, it's in great shape, and so we know this problem is largely air leakage related. And I can tell now that the poly vapor retarder isn't sealed right here along this edge. Additional evidence of air leakage is the fiberglass insulation inside the rafter bay here is completely dark. So for years, air has been leaking in here, and that air transports dust. And so as the dust travels through the fiberglass, it gets deposited right along here. Now we're looking at the other gable end, and here, along the length of the gable end, years ago, the builder applied caulking at the joint where the paneling meets the log wall. Even so, you can still see that the water staining has continued. And the reason that happened is this is a really ineffective way to air seal. Basically, it doesn't work in situations like this, because even though you might be air sealing right here along this intersection, indoor air can get through every one of these tongue and groove joints, and inevitably air will get behind the paneling and travel all the way along the ceiling and exit right out here, as evidenced by the water staining. So caulking is just not a good solution in this place. I cringe inwardly every time I see paneling applied directly over studs or over rafters, as it represents many, many small holes in the vapor retarder. In this ceiling, it's 11 feet by 23 feet. There's over 800 nail holes penetrating this vapor retarder. That really starts to add up. And in this case, this particular roof is really well vented. There's a 2-inch airspace above the fiberglass insulation. So if any air leakage takes water vapor into this rafter bay and it condenses, it's got a drying path out. But even if moisture isn't a problem, every hole represents a potential energy drain. So from a best practices standpoint, when we repair this ceiling, we're going to install furring, 2x4 furring, directly over every rafter, and that way all of the paneling nails will go into the furring, and the vapor retarder, the new vapor retarder, will be protected. So what we've got here is a great example of air leakage past a paneling nail. You can see the fiberglass is dark here, right in the insulation adjacent to this rafter. And so for years, air has been escaping past this hole created by the paneling nail, and the dust in that air is filtering out in the fiberglass. If we look at this ceiling in its entirety, every rafter is dotted on both sides with dark spots just like this. There's probably between 50 and 60 spots where air has been leaking through this vapor retarder. And people sometimes ask, well, isn't that also a problem with drywall? And no, it isn't as bad, because drywall is an engineered product. It's meant to be flat, and we're using screws nowadays. So long term, the drywall tends to stay flat and compress and seal this vapor retarder to a much higher degree than the paneling does. You've got to remember, paneling is wood, it's dynamic. And so when we look at this piece of paneling, it's cupped about 1/8 of an inch in the center. And what that means here is that there's an air gap between the panel and the vapor retarder, so there's an air pathway. And I guarantee you this paneling here wasn't cupped when it came out of the mill. It was nice and flat. But as it dried, and over the years, due to changes and seasonal changes in humidity, this paneling moves. The other thing that happens is people will varnish the front side of the paneling, but almost never varnish the back. So the paneling responds differently on both sides to changes in humidity. That also can introduce cupping and panel movements. Also, looking at this vapor retarder, we often get asked, can I put my new vapor retarder right over my old one? And in theory, sure you could. In practice, I would say no. In every case, you should typically remove the old vapor retarder. Remember, vapor retarders are never perfectly flat in cases like this over insulation, so you're just compounding the issues when you add another layer. It's far better to remove the old layer, start anew, and try to get that new layer as flat as possible. And also, this old layer is going to interfere with sealing around the edges. So generally speaking, remove that old polyethylene and put on new polyethylene, and that's what we're going to do. Once we removed the vapor retarder, we went around and carefully inspected the insulation in the ceiling to make sure that there were no voids or any other problems, and we fixed areas that needed a little bit of extra care from the original install. And we did discover a particular problem, and that is that a squirrel got into this rafter bay. Unfortunately, the squirrel was only limited to this rafter bay, but you can see that once you remove the insulation, a lot of it is missing down here at the bottom, and the squirrel carted that off to another nest in the woods. And once a rodent gets in, they can be incredibly destructive. We removed a sample section of the insulation in the same bay further up, and you can see the squirrel tunneling activity continues. And for all we know, this tunneling could have continued over the ridge and back down the other side into the other rafter bay on the opposite side of the roof. And the reason this happened is a vent screen was used, and this is a common mistake. This type of vent screen, it's a flexible vent screen, it's insect screen, but it's usually what you'll find in the lumber yards, and it doesn't work for rodents. A determined squirrel is going to chew right through this. A far better choice is a heavy gauge galvanized hardware cloth, and there's a couple different styles out there. And so what we'd recommend is installing the hardware cloth to keep the rodents out, and then for insect prevention, you can put the vent screen over it. Large insulation bats are heavy, like these R38 bats here, and oftentimes they tend to want to fall out of the ceiling simply because they're fighting gravity. This isn't necessarily a problem with the fit of the bat. The bat is having full contact on both sides of the rafters, just like it should per manufacturer specifications. But in order to get this vapor retarder on here flat and avoid wrinkles, we want to get these bats reasonably close to being in plane with the rafters. And what I'm using here is a 1-inch strand reinforced packing tape. And if I have to, I will do an entire ceiling like this in rows and staple on this tape just to give myself a flatter working surface. A lot of times on these old roofs, we'll find gaps between the bats, and those gaps are our worst enemy. So we want to make sure any gaps are filled and the insulation that goes in is well fitted and snug. We want this to look like a new roof before we put the vapor retarder on. For illustration purposes, we've cut a section of vapor retarder to 2 feet. That's the length of our ceiling, because it would be difficult for us to film installing a full sheet in the small space we have to work with. And this is a cathedral ceiling, and at 24 feet wide, cathedrals are notoriously difficult to get the vapor retarder installed nice and flat and wrinkle-free. And so when I do this, the first thing I do is I clean the floor all the way where I'm rolling out the vapor retarder so that any dust and dirt on the floor won't cling to the vapor retarder. It makes it a bear to work with when the vapor retarder is covered in dirt and you're trying to work underneath it. And any dirt that's clinging to this vapor retarder can also affect the sealing of the acoustical sealant when it comes time to seal the vapor retarder around the edges and the overlaps. And when I'm ready to cut the vapor retarder, I'll start with a brand new utility knife. It makes the whole process so much easier. And then I will roll my vapor retarder out from end wall to end wall, and I'll give myself usually another foot up the end wall to make sure I've got plenty of extra vapor retarder on the ends. And we've already got this drawn in here, but once I've got the vapor retarder cut to length, I will go along my factory edge here at the top of the vapor retarder, and I will measure down 8 inches right at my corner, and I will draw my corner in, and then I will measure out 4 feet, and I'll make another mark at 8 inches, and then I will draw a line that's parallel to our factory edge at 8 inches. And this is a reference line we're going to use later when we install the vapor retarder. Once I've got my reference line, my starting line established, I will go along the length of the vapor retarder about every 4 or 5 feet, and I will make an 8-inch mark with my permanent marker. Once I've got my vapor retarder marked, then I'm going to install it. And this is where things get kind of important. I try to hang this vapor retarder with a minimal number of staples to begin with. And so what I'll do is I will staple my vapor retarder at the corner with 3 or 4 staples at my starting point. Then I'll go out about 12 feet. In this case, that's the middle. And I'll put 3 or 4 more staples at my mark. And then I'll go to the opposite end and put 3 or 4 more staples in at the end. And every time I staple the vapor retarder, I try to pull it nice and tight. Once I've got it stapled at those 3 points, I can take a look at it and see how straight it is and make any adjustments. After I like the way the vapor retarder is hanging along the ceiling there, right at that peak mark at the beam, then I'll go back and staple in at every 3 or 4 feet along the length of the vapor retarder to make sure that it's nice and secure, so then I can pull the vapor retarder down nice and flat and staple it to the rest of the ceiling. I want to point out that we have put painter's protective paper on this glulam beam. And the reason for this is the Tremco acoustical sealant, if it drips down on this beam when we're trying to seal around the perimeter, it's going to be almost impossible to get out of the wood later. So this is a cheap preventative measure. And now when I install a vapor retarder like this, I start off with my reference. Here's my end wall, here's my extra, and here's my 4-foot parallel line, 4 feet long at 8 inches from the edge. So when I go up here, I move my starting point right into the corner where the first rafter is, and then I sight right along here along my line, and I move this line right up into that corner where the second rafter is. So now I've got a parallel line right at 8 inches at that crux of the 2 rafters where they meet the beam. Now I will go over to this second rafter, and about 6 inches down the rafter, I will run in a staple, just like that. And I'll put in 4, because I'm going to be pulling on this a little bit hard. But now this is the place we start. We know that we're parallel when we start at 2 feet. Now we can go to the middle and staple the center. Now that I'm at the other end, I'm going to do the same thing as when I started, and I'm going to staple my vapor retarder to the second rafter, not the one that's all the way at the end. You could do the one all the way at the end, but sometimes that makes it harder, especially in tight quarters, to run the caulking gun and get a good seal without making a mess. So when I staple here, I'm going to do the same thing. I'm going to go to my mark, I'm going to put some tension on it and run 4 staples in. Now in theory, that should give me a reasonably straight vapor retarder, and I can go back to my 4-foot marks and run 1 or 2 staples in at each point so that my sheet is securely fastened along its length. With the sheet fastened along its length, then I go to the middle and start working my way downwards. And I can tell pretty quickly how flat and straight my sheet is and make a few adjustments if needed, but usually they aren't needed. And you've got a strong, straight base, straight line that you can then work out your vapor retarder on the rest of the ceiling. Now that we've got our actual vapor retarder hung here, there's another point I'd like to make, and that is, in many cases, the vapor retarders will have the creases, and you can use those to your advantage. These creases in the vapor retarder are usually manufactured straight and square to the sheets. And so in this case, when I was able to hang the vapor retarder, I could put my marker line right on top at a crease that was close to the edge and line up along that crease right at the peak to keep everything straight. At the end of the day, it doesn't matter so much how you do it as long as the end result is a nice, taut, straight sheet that's parallel to your ridge. And when we get started, we're going to work our way down from the middle and outwards in a large triangle to make sure that this vapor retarder goes on flat. And if there's any issues with straightness, those will show up right away, and then you can make adjustments if you need to. Hopefully you won't, but if you do, that's okay too. Our go-to sealant here in Alaska for vapor retarders is Tremco acoustical sealant. It's one of very few products that has incredibly good long-term adhesion and air sealing ability for polyethylene sheeting. And in this case, I've run a very generous 3/8 bead all the way along the top of this ridge beam. And it doesn't end there, because remember, this roof failed primarily because there was air leakage around the old vapor retarder all the way around the perimeter. And to prevent that, we need to follow best practices and be able to clamp our vapor retarder to our ridge beam. And what we've done is we've ripped a pitch block that's going to run continuously along the top of this beam. But because the pitch is so steep, there's always a chance that the vapor retarder isn't installed high enough and that this sharp edge on our pitch block could cut the vapor retarder over time, or even right at install. So when we rip our pitch block out of a 2x4, we make one more cut and we take that sharp edge off, so that when I install the pitch block up here, I'm clamping directly over my Tremco, my acoustical sealant joint, and I've got a relief. In case my plastic is hanging down just a little bit too far, it won't get stressed and eventually tear. This is an incredibly vulnerable area for air leakage, so I feel that putting this continuous block up here is well worth the effort for a long-term durable air seal. People sometimes ask whether it's necessary to put vapor retarder tape over each of the staples that's holding up the polyethylene sheeting that's holding up our vapor retarder. In cases like this, I don't have strong feelings on it, because the staple itself, it's pretty minimal of a puncture. And remember, we're putting with screws a furring strip directly over that staple. So this is a clamped connection. And so the long-term potential for significant air leakage here is minimal. But I get it. The flip side of the coin is some people want the most absolutely perfect air seal you can get. And so if you feel that way, then you could take vapor retarder tape and seal every staple. An efficient way to do that I found is I'll just lay out a stick and I'll just quickly cut a whole series of small pieces of red tape. And then I can carry this with me when I'm up working on the ceiling, and I can just peel off sections and cover my staples. So that's just another tip for the toolkit. Here we've got one side of our ceiling completed with all the furring. As you can see right along the bottom, we've got a continuous pitch block that's clamping the vapor retarder to the wall directly over the Tremco joint. It's the same pitch block that we used up at the peak, except we left the long point, the sharp corner on. And people ask what kind of fasteners we use on furring. And you could use nails, but in this case, we used GRK R4 number 10 screws. These are a very robust screw, and they provide a good long-term connection here. Be careful when you buy these screws, though, because there's also a number 9, which isn't quite as stout. This roof ran the furring in line with the rafters because the paneling ran perpendicular to the rafters, but it's just as easily run directly across the rafters. It just depends on which way the paneling is oriented. And another unusual feature of this roof was there were no electrical outlets in the ceiling, but typically in a project like this, you would want to move all of your electrical out of the vapor retarder onto the warm side. And to do that, you would use an 1.5 inch shallow electrical box. It's got nailing fins, and it can mount right here on the furring, so that way all your wiring and electrical run on the warm side. There's no holes in the vapor retarder. Thanks for watching. We welcome your comments.